Have you seen the movie Interstellar? Well, in that movie, the Earth turns uninhabitable, and so the former pilot Cooper, who is about 40 years old, and father of a little girl who is about 10, is forced to leave planet Earth in order to find another habitable planet to ensure the existence of the humanity. While they are looking to fulfill their mission, Cooper and the other astronauts spend only 5 years in space, or at least from their point of view, because at the end of the mission, Cooper, who is now 45, meets his daughter, who is now 80 years old. Did you hear what I have just said? Cooper only spent 5 years traveling near a black hole, and in that time, 70 years passed on Earth. Basically, Cooper had traveled 65 years to the future. But how did he achieve this? Well, we'll explain it in the next few minutes, and we will learn how to time travel.
But before we start, we have to make clear two ideas that are known thanks to the theory of relativity, that theory that everyone knows but no one understands. The first one is that time is one more dimension, although it differs from the others because it's not a physical dimension. We cannot perceive time with our senses, we cannot touch it or see it. We must point out that we are constantly traveling forward by the dimension of time. We are always traveling to the future. The second thing we must understand is that according to Einstein, time is not absolute. It doesn't pass at the same speed in all places. It can be delayed or contract. And from this, we could actually time travel. But we will see this more in depth during the rest of the video.
Okay, now let's talk about mass and density. A golf ball has more mass than a tennis ball, regardless that the tennis ball is bigger. This happens because the golf ball is much more dense. This means that it has more matter in less volume.
I don't understand. What is the mass? And what does it mean that an object is more dense than other?
The mass of an object is the quantity of matter that is in it, and its unit is a kilogram. Then there is the density, which is the quantity of matter in a determined volume of an object. A denser object has much more mass in less volume or size. That's why we said that the golf ball is more dense.
This is so boring.
Okay, yes, I know, this part was very boring, but now it's gonna be more and more interesting. We're going to dive in deeper into our amazing universe.
Do you remember that we said that time was a dimension? Well, that dimension is so related with space that we should talk about a spacetime.
And what does this mean?
The universe is full of massive objects, gigantic or tiny objects, but massive. Einstein proposed with his theory of general relativity that these objects can curve the spacetime around them.
What?
Well, it's not easy to explain, but it imagines spacetime like a bedsheet and the massive objects like marbles. The more massive the marble is, the bigger will be the depression created in the bedsheet. That in this case represents the spacetime curvature. This is a good example, except that the bedsheet is a bidimensional space while we live in a tridimensional one. So the effect caused by the massive objects, like the planets, would look something like this.
Now you understand that the massive objects, the marbles, curve the spacetime, the bedsheet. But let's see, how is this related to time? Well, the answer is right in what we learned previously. The space and the time are connected. That's why it's called spacetime, and if one of these two changes, the other one changes too.
But the question is, what consequences brings this spacetime curvature?
Here's where the best part starts. The spacetime curvature is what causes gravity. This means that an object with more mass generates a bigger spacetime curvature and so a stronger gravitational field. For example, on the Earth the gravity is stronger than the Moon because our planet is more massive.
The reason why this is related to time is exciting and amazing. According to the general relativity, the stronger the gravitational field is, the slower the time passes in it. But we need to explain this, because it's not that easy as it looks like. If we were in a place where gravity was stronger than in our planet, we would feel that the time passes as usual. We would be counting seconds as we did in our planet. Maybe this is not clear at all, but we're going to explain it with an example.
Let's imagine that we go on a vacation 10 days to orbit a massive and dense object like a black hole. These ones, as you know, generate an enormous force of gravity. Okay, you may think this is a weird place to go on a vacation.
If we stood near a black hole, we would feel that the time passes normally. But one day orbiting the black hole could be, for example, 1 year on Earth. Having been 6 days orbiting the black hole would have been 6 years, and after having spent 10 days, 10 years would have passed on Earth. Although it would be difficult for this to happen, because we should be in presence of an incredibly massive body. This phenomenon is called time dilation. It's amazing, isn't it?
Well, now that we understood this, let's explain how we could time travel to the future. In the center of our galaxy, there is a black hole that has 4 million times the mass of our Sun, and a size of 6.7 billion kilometers. Yes, it's enormous, but if the Sun became a black hole with this density, its radius would be of 3 kilometers.
It is almost a natural time machine. Imagine that we could approach to it, obviously with many precautions. We should place ourselves at a reasonable distance from its event horizon, which is an imaginary boundary that we can call point of no return, because nothing, not even the light, can escape from there. If we could orbit correctly this monster, we would be affected by its gravity, and so the time would pass much slower. We could make 100-year leaps into the future. Then, we could say that it is confirmed that we could travel in time this way.
Likewise, things are not so simple, because the black hole that we were talking about, Sagittarius A, is 26,000 light years away from us. So for now it will be a bit complicated to get there. So we'll be able to travel through time as soon as we invent spacecraft that can travel 1,000 times faster than light. We mean, it would not be difficult to time travel to the future because of any reason but the distance between us and this really massive object, and also, obviously, because getting close to a black hole would be excessively dangerous. So for now, it will be better to focus on the present. But is time dilation proved?
Yes, it is. We can see it in super accurate clocks, called atomic clocks, and we can find them in GPS satellites. They go 45 microseconds ahead per day because they orbit the Earth at a very high altitude, and consequently, the Earth's gravity affects them less. This example is important because it serves to remark that time dilation is not important only because of the possibility of traveling through time with its effects, but also because it serves in our daily life. As we said, without calculating its effects on artificial satellites, your GPS wouldn't be so precise as it is today.
But before ending with the video, I want you to reflect on something. Did you ever heard that Albert Einstein was a very bad student? You've probably heard about this, but hey, I'm sorry to tell you, but this is a lie. Albert was never a bad student. He always excelled in his schooling. He was not an idol. We cannot live in that famous false myth. If we don't strive to improve, we will never become what we want. It is not enough to excuse, if Einstein was a bad student, I can be a bad student too, and then become a genius. But beware, this doesn't mean that because you struggle in school you will not be able to reach your goals. You can work hard and not have good results in school. But that's it, effort, no genius. None of our idols came to be who they are without effort. Or do you think that everything that we talked about in this video came to Einstein's mind from one day to another? No, it didn't happen that way. This man was a genius, but not only intelligence was his best skill. Most of his success was hard work.